Good morning, ladies and gents. I hope you had a good day yesterday. Okay, so going over our practice quiz. So the first question said use Pythagorean theorem to find the height of the triangle. So we had an 8 centimeter equilateral triangle sitting there. So I drew in the height, marked at H, and then we're paying attention to this half of the triangle over here to get the height. So this bottom would be 4 centimeters. This long edge would be 8, and obviously the right angle is sitting right here. Okay, so a squared plus h squared equals c squared. So this would be 4 squared, h squared we don't know, and then in the place of c would be 8. Square 4 and 8, take 16 away from both sides. I'm left with h squared equals 48. Square root both of those sides, and the height comes out to be 6.93. Again, if you're using this answer in the middle of a question, you may want to leave it as square root 48. Your calculator will understand that, and then you don't have to worry about rounding errors. So again, like bringing this even to 6.93, even to the hundredths place, I've made it slightly inaccurate. Now, when I multiply that by 8 in the next question, I've made it 8 times more inaccurate. So leaving it square root 48, that's still an exact answer, and it's nice and neat, so you don't have to worry about writing too much or making your question inaccurate. Okay, so question 2. Calculate the area of the triangle in question 1. So area of a triangle is base times height divided by 2. So I've written that down. The base of this triangle is 8. Its height, we just found out, is square root 48. So run that through the calculator. You get 27.71 centimeters squared. Okay, calculate the area of the hexagonal base. Again, when you take this hexagon and you break it up, you get 6 equilateral triangles sitting in here. So we can take the area that we just calculated of one of those triangles and then just multiply by 6. So 27.71 multiplied by 6 of them, and that tells me that this hexagon on the end is 166.28 centimeters squared. Now that we know that, find the volume and surface area of the hexagonal prism. So volume is going to be area of this hexagonal base multiplied by how tall it goes. So you're imagining that it's sitting on this hexagon and then this is going up, okay? So when I say height, it's not height of the triangle, it's height or length of the entire prism. So please watch out for that. I saw in a couple people's assessment focus questions they handed in that mistake was made. I got height of the triangle being put in for here. Oh, excuse me. Sorry about that. And again, it's the length or height of the entire prism when it's sitting on this end. So area of the base, we just calculated it. It's 166.28. So that's this. Multiplied by how tall the whole thing is, 25 centimeters. And that gives you the volume. So all the space on the inside, 4,156.92 centimeters cubed. For surface area, we're adding up all the areas of the whole thing. So we have 2 hexagonal bases. So that's this. Surface area is equal to base area times 2. That's the 2 hexagons. And then we have the rectangles. The rectangles are 8 wide, 25 long. So that's where this comes in. Okay, so there's our rectangle, and then there's 6 of them going around on the outside, 1 for each side of that hexagon. Okay. So I explained where all that came from. Now just following Bedmeth's multiplication first. So 166 times 2 is 332. 8 times 25 times 6 is 1,200. Add those together, and you get a surface area of 1,532.56 centimeters squared. So that's as far as it's going to go on your test. If you can do this, that's great. You will see a question very similar to this on your test, just like the assessment focus from the page before was basically the same thing as what you did here, just different numbers. So if you've practiced this and you get it and you know how to put it together, you will be fine. So on to number 5, just the extra challenge one. So what I've done, here's his suitcase, okay? I went and I put the measurements on. So it's 65 centimeters long, 25 wide, 30 high. To figure out if his umbrella is going to fit, you have to do Pythagorean theorem twice. First one is just going along the very bottom of the suitcase to figure out this measurement, how long it is diagonally across the bottom of it. So, and then I might as well explain it to the end. Then once you know this distance, what you're going to do is this purple line kind of represents the umbrella. So it's going from that front bottom left corner up to the diagonally opposite back top corner. So it's going through the suitcase from bottom to top diagonally, okay? Because that's going to be the longest space in there. So this first Pythagorean theorem will just be figuring out diagonally across the bottom. So a squared is going to be right here. This is A, 25 centimeters. B squared is going to be going along the back, and that's 65 centimeters. And this will be C squared, and then we'll know how long that is. Okay, so 25 squared is 625, 65 squared is 4,225. Add them up. I get square root 4,850 or 4,850. And then I know this one's 69.64 centimeters long. Now that we know that, we're going to do it again, but except this is our right angle triangle. So there's the back of the triangle. The 90 degrees is right here. Okay. So it's kind of taking us a diagonal slice through the suitcase. So this is A squared, 30. This is B squared. We just figured it out. It's 4,850 or square root 4,850 long. And then this will be our C squared, where we're hoping the umbrella is going to go. And as long as it's 75 centimeters or slightly longer, it'll fit. So here we go. This edge, 30 squared. B squared, we know, is 4,850. We just calculated that, and C is what we want. 30 squared is 900. Add them up. I get 5,750. Square root that to get C, and we get 75.83. So the umbrella will fit just barely because it was 75 centimeters long, and it's just barely over 75 centimeters. Okay, hopefully that makes sense. If you have questions, obviously, you know how to reach me. Bye for now.